The probability that a car has a certain defect is 8 out of 25. So let's say probability of D is 8 out of 25. The probability that a car has a certain defect and needs an oil change is 7 out of 50. So the probability that a car has that defect and needs an oil change, we'll say O for oil. Really inventive of me, wasn't it? 7 out of 50. That's the probability of both of those things. What's the probability that a car needs an oil change? So probability of O given that it has a defect. That's what we're asked to calculate. So a conditional formula says that if you're trying to find the probability of one event given another event has happened, it's the probability of both of them. So you could say O and D, or you could say D and O. The order doesn't matter, right? I have a blue shirt and I'm sweaty. It's the same event as saying I'm sweaty and I have a blue shirt. Alright, so that's the conditional formula. So we already know this one. We already know this one. You could just plug them into the formula. Let me think if there's an easier way. No, I think we've been doing the formula written like this. You could multiply both sides by probability of D to rearrange the formula, and that works too. But so to find the answer they're looking for, the probability of an oil change, given that it has a certain defect, it's the probability of both of them, 7 out of 50, divided by the probability of the defect, 8 out of 25. That's something we can take off to the side here and do some fraction work. 7 out of 50 divided by, here's just another way of writing it, divide by 8 out of 25. You can flip and multiply the second fraction. And when you do that, you can cross simplify. Both these can be divided by 25. So 7 times 1 makes 7. 2 times 8 makes 16. So we got 7 out of 16. I think that's it. Yeah. Felt like I was missing something there.